So this is kind of recapping what we talked about this morning, and I know most of you are not math. Maybe you've learned some math along the way or had some math clarified. Hopefully you've got some teaching strategies and ideas and some resources. But we stopped with univariate. Univariate, un as a prefix means one. We had one data set. We had some temperatures we were looking at. The world does not revolve around one statistic, however. The world really revolves around relationships.
And even with that one, there were so many things to talk about. You had box plots, you had dot plots, you had the mean, the median, the mode, the first quartile, the second quartile, third quartile. Lots and lots of things that you can do. You can spend half a semester on univariate statistics if you really want to, and dig in and act like that miser that's running his fingers through coins. Just run your fingers through the data, analyze it 10 ways from Sunday, think of different ways to make deductions, okay? But we don't want to stick with one.
So you have this chart on the inside of your handout, if you want to annotate as we go. Yeah.
So if we want to do more, what the heading is bivariate. Bi means two, so that gets you started. What do you think you're going to do if you're going to switch from 1 to 2 in the world of number lines and graphic representation? You're going to move from a number line to what?
Cartesian.
Ooh.
Yep, we got it. Cartesian coordinate system.
Cartesian, that's a great history lesson right there about Descartes and the fly on the wall.
And there's a really great joke. Okay? And when you're doing dots, the dot plot on the number line, now what's the word in the Cartesian coordinate system?
Plot. Slope.
You get something plot.
S, SC, SCA.
Scatter plot.
Scatter
Ooh,
plot.
only took you 3 letters that time.
Yep. Scatter plot. So the dot plot moves into 2 dimensions. That becomes a scatter plot. And the purpose. Okay, now think a second. Let me warm this question up just a little bit. The purpose on the univariate model was to get one number that represented a series of numbers. We've already said we're in 2 variables. When you have 2 variables, what are you getting? What mathematical quantity are you working for?
Trying to get a best fit line usually.
Location.
You want some location information.
I didn't hear what you said over here.
When you've got one,
I generally deal with best fit lines when I have scatter plots.
Best fit lines. Everybody heard of best fit?
and what is a line? It's an example of starts with F. Function.
Ooh, one
Okay.
letter.
So univariate statistics deal with single numbers. Bivariate statistics deal with functions. So you find functions to replace your data so that you can do predictions. So in univariate statistics, you're getting a single number to replace a collection of numbers. In bivariate statistics, you're getting a function, which is a relationship that represents 2 collections of data. 2 variables, what are they called? One starts with I.
Independent and dependent.
Independent and dependent. So you're not replacing a list of numbers with a single number, you're replacing a collection of pairs of numbers with a relationship between an independent and a dependent variable.
And this actually starts, the concept of function really begins in kindergarten with input and output. We don't formally call it that, but it blows up into middle school. By the time they get 6th grade, they're getting distance, rate, and time. They begin looking at relationships, and in 7th grade, they are full thrown into the idea of slope and independence and dependence, domain and range, and those relationships. The world in which we live is full of relationships, right? We model our world, whether it's the science aspect, whether it's the food aspect, whether it's health industries, whether it's agriculture. We modeled that with functions. So function-based mathematics is the foundation for middle school and high school.
Okay, so pass these along, and we are going to have a brief moment with a manipulative. And Tammy has the manipulative, and it is uncooked spaghetti. Okay, so you have 4 graphs that have scatter plots. We're going to look at 1, 2, 3, 4 in this order. So here's example 1. The question is, if we said we need a function, the simplest function in the world is a line. Now, I better hear a uniform answer to this question, okay? How many pieces of information do you need to write the equation of a line? 2. You need the tilt, called the slope, and you need where to put it up or down on the page, right? So that we use the intercept for. So what you're going to do is take the spaghetti for your line, and you're going to run it around until you think it fits that first data. So you're going to lay it down and tilt it on the page until you think it fits the data. You might even take, once you've got it where you want it, you might even take your pencil or pen and draw the line in using the spaghetti as your straight edge. You don't have to, but you can.
Now, if you look at your neighbor, did your neighbor place it exactly where you did? This is why statisticians usually graduate and make 6 figures starting out. It's also why with every statistics major there is a course called ethics. Remember Enron? Some of us that are old enough to remember Enron. You can take statistics and make anything happen. And there is an ethics involved in that. So as you're doing this in the classroom, if you're a math teacher, we used to actually talk about misleading statistics even in kindergarten and first grade. That's kind of left with the Common Core. But this is the perfect example. Look at your neighbor. Do they have theirs laying exactly the same way you have yours? Who has the better fit? How do you know?
And why did you put it where you put it?
So what was your thinking?
Somebody tell me, somebody tell us, what were you thinking? Why did you say that was a good line? What were you looking at?
I looked at that it went through the origin, its y-intercept, and it covered the most number of slots.
So if it goes through the origin, by definition, mathy, we're going to get a little mathy here. We don't apologize. That's what we're doing. That's why we're here. Anything that goes through the origin, we automatically call a what? D, DI, DIR, direct variation. That's where they begin in middle school. If it goes to the origin, it's a direct variation. What does a direct variation mean? If I turn the heat up in the winter, what happens to MTSU's electric bill? Versus if I turn the air down in the summer, what happens to the heating bill? It still goes up. That would be the indirect form, right?
They move in the same way, it's direct. If they move in opposite effects, it's indirect, okay? But I still need to know why you, even if you went through 2 points, how'd you pick which points?
Let me ask you, like I ask my students, how many of you tried to zap points? How many of you tried to catch the most points? Be honest, how many of you tried to catch the most points? That is what you are, I would give you red checks if you were in my classroom because you're honest. That is what most students do. They try to place the spaghetti to catch the most points. And this is where the rub comes in statistics. Do you always want to catch the most points?
So do you want a clock that's 10 minutes slow and is never right, or do you want a clock that's stopped and is right twice? Being right twice is catching points, right? You caught 2 points. If the clock is slow, it's 10 minutes, consistently 10 minutes slow. You can work with that. It's never right, but you can always fix it in your head. You'd rather have it telling time, even if it's a little off, than only being right twice a day.
Yeah, in a classroom, this will be a lesson that we would probably do over a day or two, so we wouldn't go straight to the punchline and say,